Hello everyone, welcome to the project demonstration. The name of our project is USB PC Shutdown System. This project is assigned to Sessional Group 4 of EEE 316. The goal of this project is to design a system which should monitor the main power line, and upon detecting a power outage, it should shut the connected computer systematically. The communication between the host PC and the system should be through USB. There are two working sides in our project. One side is the host side and another side is the remote device. The work of the remote device is to detect a power outage on a pin and pass this state to the host side. The work of the host side is to receive that passed state and work accordingly. The remote device is a microcontroller based system which monitors the state of a power line, conveys the monitored state to the host computer via USB. To monitor a power line, one of the 40 pins of 80MeGA32 is used. The 220-volt power line is stepped down by an adapter and regulated by a 7805 IC before connecting to the microcontroller. To establish USB communication, the virtual USB open source package from OBDAEF at .AT is used, which is freely available. Among the available USB device classes, we have used the custom class, which allows for maximum flexibility at the expense of complexity. So far, we have programmed the remote device to monitor power line connected to the pin PB0. The remote device will only inform the host about the state of the power line. The host must have a software that can receive the sent data and take necessary action. Once a pipeline has been installed, we can easily monitor the power line continuously. The host continuously requests the data from the device, and when the received data indicates that the power is off, a function is called. This function is written to properly and appropriately call the Windows system function associated with shutdown, such that exit windows.ex. It should be clear at this point that this device is not limited to shutdown only. Instead of shutting down, the detection of a power outage on a line can be used to set off any event, as long as the developer is aware of the know-how.
Hello everybody, welcome to the demonstration of the project USB PC Shutdown System. As you may already know, this project should detect when the main power goes offline and then proceed to shut the connected PC off systematically. For that, we have designed this circuit board. As you can see, there's one IC, this is the 7805, and one microcontroller, this is 80MeGA32 microcontroller. Now, first step is to let the microcontroller know whether there is a power in the main line or not. For that, we here connected a jack. It's a jack for an adapter, because obviously we cannot connect a 220 volts to this microcontroller. So we step the voltage down to 5 to 10 volts DC by this adapter, and then via this jack that voltage is inputted into this 7805 IC. The output of this 7805 IC will be a regulated 5-volt output that will be connected to this pin number 1 of this microcontroller, or better known as pin PB0. Essentially, this pin shall let us know whether there is a power in this part of the circuit or in the main line or not. Essentially, we have to let the PC know the state of this pin. For the USB connectivity, we have used this bit of circuitry. This is the USB communication circuit widely available in the Objective Development Forum. We have taken it from there. And these three LED, they are indicator LEDs. They are connected to pin A0. Pin A0 doesn't do anything actually. Pin A0 is assigned to be exact opposite of pin PB0, so that whenever there is power in pin B0, there is no power in pin A0, and this LED indicator, they are off. When the power goes off, then this pin is 0 and this pin goes 1, and this pin shall blink to indicate us, sorry, they don't blink, they will just light up and indicate us that there is no power in the main circuit. And via this circuitry or via USB connectivity, we shall let the host side know of the state of pin PB0. Whenever pin PB0 will go off or will go to 0 state, then the host side will know that there is no current, and whatever the host side does with that data is up to the host side. For this project, we have developed a software which shall detect whenever this pin goes to 0 and then shuts the PC down systematically. And just to demonstrate the sheer power of this flexibility, we have also added some extra features which shall launch upon the main power shortage, and we shall demonstrate that shortly. This is our project board in action, and we have connected our project to the USB through this wire, and we have connected this microcomputer to the main power line through the 7805 and ultimately through this adapter. This adapter here is telling us that the power line is on, and which is reflected by this LED. As long as this LED is on, we have to understand that the main power is on and no action shall be taken. But as soon as this LED goes off, the main power is off and this LED lights up, indicating that the current is gone. And we have to transfer this knowledge to the PC that we have done through this USB, and we shall soon demonstrate how our PC uses that bit of data.
We have seen our circuit board in action. Now it is time to see whether the host side actually does its job.
we can see from this icon our device is recognized by the PC as power switch, and this is our graphical user interface. This GUI is made so that the user can access our device easily and smoothly. Our device can perform many jobs. Since our primary job is to shut the PC down according to power outage, we are selecting shutdown mode. For that we click on mode and then click on shutdown. Then we are prompted for delay. This is designed so that we can get some time between power outage and PC shutdown. Suppose we are giving 10-second delay. Then we start checking by click start checking. Instantly a software is launched which checked the state of the power. This indicates that the power is on. When the power goes off, that state is reflected by this software. You can see here the LED is off, which indicates that the power has gone off. And then we start the countdown from 1 to 10. It's actually count up. After the count is over, once again that software is launched to check whether the power has actually gone off or if it's a temporary fluctuation. If after 10-second delay the power is still off, then we know that it's time to shut the PC down. So we take according action. So this is the screen which says the PC is going to shut down after a certain amount of time. Please save your data. That indicates our project is successful. We already demonstrated the shutdown part of our system. As we have previously said, since we have selected the custom class, there is much versatility in our project. To demonstrate that, we have added some extra features. Number 1 is an alarm system, which would ring an alarm when there is no power. Number 2 is a launch Google system, which would launch a Google search by this string, which is written here when the power goes off. And the third is the most powerful, the send mail system, which would send a mail to a preset address when there is no power. To demonstrate our extra features, we first click on the mode, then others, then alarm system, and then we start checking. This software detects whether there is power or not, and if the power has gone off, then it launches an alarm, which we can hear. We have already demonstrated the alarm system of our project. Now we are going to demonstrate the extra feature send mail. For that, mode, other, send mail, and I'm going to give my own email address, and then I start checking. When I find the LED is off, this device finds the LED is off, and then it starts a sequence which shall send the mail to the specified email address. Now I'm just going to open my own inbox. And sure enough, I've got an email from usbshutdownsystem@gmail.com, which is the email address of my device, with the subject power notification. Let's see what this email address has to say. This email address has sent me when and at which date the power has failed. This feature can be very useful for an engineer who has to check a grid but cannot be there all the time.